Oh no! Now my ice cubes have melted and my wine doesn't taste the same. The alcohol percentage is lower. Such a waste of fine wine.
That's because your wine now contains a lot more water, but don't worry, we can redeem that.
Seriously? How?
Hello and welcome to the Maastricht Science Channel. Today we'll explain the transition between states of matter and how intermolecular bonding affects boiling points of substances, including how that can be used in separation of different liquids. A fundamental difference between substances is the distance between the atoms, which we can define as their states. There are three states of matter: solid, liquid and gas. The difference between those three states is the behaviour of the particles, or in other words, intermolecular interactions between those atoms.
In this cocktail, the particles are in clusters and are able to move relative to one another, which is a typical property for a liquid. The ice cubes are in a solid state. They have a stable structure with regular pattern and are tightly packed together. As the internal energy in the ice cubes increases, the intermolecular interactions weaken and the particle distance increases, resulting in the state change from a solid to a liquid.
Water can be separated from ethanol using distillation because they have different boiling points. Both these molecules are polar and have similar intermolecular interaction known as hydrogen bonding. In a water molecule, there are two slightly positive hydrogens, and they can both attract slightly negative oxygens of the water molecules, forming strong hydrogen bonds.
In contrast, ethanol has only one slightly positive hydrogen and a carbon chain that induces covalent nonpolar bonding, decreasing dipole-dipole moment. This results in ethanol evaporating at a lower temperature, around 78 degrees, whereas water boils at 100. Based on that, we can heat our liquor to about 80 degrees in order to evaporate ethanol and separate it from water, which will stay in its liquid form.
As we start heating the mixture, all the heat energy transfers into the molecules, which is seen as a temperature increase. When we reach about 80 degrees, ethanol begins to evaporate. It changes from a liquid into a gas. In order for the change to occur, heat energy is consumed to increase the kinetic energy of those atoms. This increases the frequency of collisions. Molecules on the surface of the solution gain more energy from those collisions and then have enough energy to break free and evaporate from the water. The temperature at which liquid reaches this threshold is known as boiling point.
Once a liquid has reached its boiling point, vapour is produced. The vapour rises as it is less dense than the liquid from which it was formed. As soon as the vapour reaches a condensation column, the ethanol condenses. Now the state changes from gas to liquid due to the change in temperature of the substance. As vapour cools down in the condensation column by water running in the outer tube, molecules become more ordered and condensation occurs.
On this graph we can see transition between the states of matter. When a liquid turns into a gas, it's called a vaporization, and when the gas turns into liquid, condensation. Once the separation is done, we can check how pure the ethanol we distilled is. The sample is run through a refractometer.
In order to get a high concentration of ethanol, we will use a fractional condensation column. The principle is exactly the same as distillation, only with fractional condensation column, ethanol evaporates and condenses back several times, allowing a higher yield of product. Now let's check the refractive index again. Now the concentration of ethanol is around 95%. Unfortunately, it is impossible to get pure 100% ethanol with distillation only. When the concentration of ethanol reaches 95%, water and ethanol form an azeotrope. Azeotrope is a mixture of two or more liquid compounds that cannot be separated by simple distillation, due to the fact that when an azeotrope is boiled, the vapour has the same proportions and constituents as the unboiled mixture. Formed azeotropes have a slightly lower boiling point than ethanol. The difference is less than 1 degree, so the product formed will be an azeotrope instead of ethanol, because it will distill off first.
Let's recap on the concepts we have introduced in this video. There are three states of matter: solid, liquid and gaseous. They differ by the distance between their atoms. Transitions between phases occur if the energy is lost or gained, and the energy is enough to alter the intermolecular interactions. Ethanol and water have different boiling points due to the difference in the strength of intermolecular interactions. Liquids can be separated from each other using distillation if they have different boiling points. In distillation process, evaporation and condensation takes place.